Hi, welcome to Bits of Food Science. Today, let us learn about food emulsifiers. First, let's understand the emulsifying process. Picture this: I have a clear glass of water in front of me. I slowly pour some oil into it, and give it a stir. At first, it may look like they're mixing, but if you watch closely, the oil begins to separate, floating back to the top. Oil and water just don't get along, they stay apart, immiscible. Now, here's where the magic happens. I add a little emulsifier and stir again. This time, something different occurs: the oil no longer separates. Instead, it breaks into tiny droplets and stays suspended in the water. Suddenly, the two liquids become one, smooth, creamy, and stable. And that's the secret behind your favorite foods. This is exactly what happens in mayonnaise, butter spreads, ice creams, and even sauces. The emulsifier is like a peacekeeper, helping oil and water, two opposites, live together without separating. So, what exactly is an emulsifier? An emulsifier is a compound that helps mix two or more immiscible substances, such as oil and water, into a stable, uniform mixture. They play a crucial role in many food and industrial products where oil and water need to blend seamlessly. Emulsifiers are amphiphilic molecules, composed of a hydrophilic head group, which associates with the aqueous phase, and a hydrophobic tail group, which associates with the lipid phase. This unique dual structure makes emulsifiers highly effective at bridging two substances that would normally repel each other. At the oil-water interface, these molecules orient themselves to reduce interfacial tension between the immiscible liquids. By surrounding dispersed droplets, whether oil in water or water in oil, emulsifiers form a protective layer that prevents coalescence and phase separation. This ensures that the mixture remains smooth, stable, and visually appealing. Their dual affinity improves the apparent miscibility of oil and water, leading to the formation of a thermodynamically stable emulsion. This dual attraction, hydrophilic to the aqueous phase and hydrophobic to the lipid phase, allows emulsifiers to act as a molecular bridge between two immiscible phases. In essence, emulsifiers make the impossible combination of oil and water possible, providing stability and uniformity in countless products we use every day. Each emulsifier must either be approved by the FDA through food additive regulations or be listed as GRA, meaning that experts recognize it as safe when used as intended. Emulsifiers are commonly identified by their E numbers. For example, lecithin is E322, mono and diglycerides are E471, polysorbate 60 is E435, and carrageenan is E407. These E numbers indicate that the additive has been evaluated and approved by the EFSA, European Food Safety Authority, for safe use in foods. Moreover, no emulsifying or stabilizing agent may be used in any food unless its use is specifically permitted under the Food Safety and Standards Regulation, 2011. Emulsifiers are classified into two main types, natural and synthetic. Let us start with natural emulsifiers. Natural emulsifiers are substances derived from plant, animal, or microbial sources. They stabilize mixtures of immiscible liquids by reducing interfacial tension, without undergoing any chemical modification. Some important natural emulsifiers include lecithin, E322, sourced from egg yolk, soybeans, and sunflower seeds, used to blend fats and water in chocolate, margarine, and dressings. Gum arabic, acacia gum, E414, obtained from acacia tree exudates, used in beverages, confectionery, and syrups. Guar gum, E412, extracted from guar beans, thickens and stabilizes ice creams, sauces, and baked goods. Locust bean gum, carob gum, E410, from carob seeds, provides viscosity in dairy products and desserts. Xanthan gum, E415, produced by fermenting sugars with Xanthomatus bacteria, used widely in sauces, dressings, and gluten-free products. Agar, E406, derived from red seaweed, used in jellies, desserts, and microbiological media. Carrageenan, E407, also from red seaweed, improves texture and prevents separation in dairy and meat products. Pectin, E440, found in citrus peels and apple pomace, essential for jams, jellies, and fruit-based products. Tara gum, E417, extracted from the seeds of the tara tree, used as a stabilizer and thickener in sauces, dairy, and baked goods. Let us understand why these natural emulsifiers are preferred. Natural emulsifiers, such as lecithin, pectin, and gum arabic, are highly favored because they are biocompatible and easily digestible. This means they pose fewer concerns regarding toxic byproducts or long-term health effects compared to synthetic alternatives. In addition to their safety, many natural emulsifiers provide nutritional benefits. For instance, lecithin supplies phospholipids that support brain and liver health. There is also a growing trend toward clean label foods, as consumers increasingly prefer ingredients they can recognize and trust. Let's talk about carrageenan and why it's sometimes considered controversial. Although carrageenan is not banned globally, some animal studies have suggested possible links to intestinal inflammation, even though no conclusive evidence exists in humans. In the United States, the National Organic Standards Board recommended removing carrageenan from the list of organic approved ingredients in 2016. However, the USDA overruled this decision, allowing its continued use in organic foods. Now let us take a closer look at synthetic emulsifiers. Synthetic emulsifiers are surface-active agents produced by chemical synthesis or by modifying natural substances like glycerol, fatty acids, or sugars. They work by reducing the interfacial tension between oil and water, which helps stabilize emulsions in food. Some commonly used synthetic emulsifiers include mono- and diglycerides of fatty acids, E471, used in margarine, bread, and ice cream, datum, E472E, added as a bread improver, polysorbates, E432, E435, E436, used in beverages and whipped toppings, and PGPR, E476, commonly found in chocolate and spreads. Now let us understand why synthetic emulsifiers are widely used in the food industry. Synthetic emulsifiers, such as E471, E472, and polysorbates, are widely used because they create more stable emulsions that can resist breakdown during storage, heating, or freezing. They are generally cheaper to produce and are available in large quantities, whereas natural emulsifiers like gum arabic or lecithin can be more expensive. Another advantage is that synthetic emulsifiers have standardized purity and consistent performance, while natural sources may vary in quality depending on the crop, season, or extraction method. Overall, synthetic emulsifiers help improve product stability during transport and storage, reducing spoilage and preventing phase separation. We have come to the end of the video. Thank you for watching, and see you again.